Okay guys, we went this far. Now we're going to talk about algebraic vectors in 3 dimension or 3 dimension. First we're going to talk about the addition of 3D algebraic vectors, okay? The sum, let's say the sum of two 3D algebraic vectors, vector A is equal to AX, AY, and AZ. Remember, in 3D there are 3 coordinate axes, X, Y, and Z. Vector B, let's say vector B is BX, BY, and BZ. If we want to add these two vectors, vector A plus B, same thing, we add the corresponding coordinate axis with the other one, which means vector AX plus BX, AY plus BY, and AZ plus AZ to find each coordinate. Let's do that with numbers, which makes everything easier. Say we got vector A is equal to -2, -4, and -8. And vector B is 5, 10, 15. We want to add vector A and vector B together. Okay? So what do we do? -2. This is let's call vector A and vector B S. So vector S, which is the addition of the sum of vector A and vector B, is the x coordinate will be -2 plus 5 is 3. And for the y coordinate, y-axis is -4 plus 10 will be 6. And the last axis, which is the z-axis, is -8 plus 15 will be 7. See how easy and simple that is with Dr. Hillman? We got the answer is 3, 6, 7. The addition of algebraic vectors in 3D. Okay, now we're going to talk about the subtraction of 3D algebraic vectors. Subtraction of 3D algebraic vectors. Now it's the same thing as the addition, but this time we subtract from the first vector with the second vector. Let's say vector A will be AX, BY, sorry, AX, AY, and AZ. And vector B is BX, BY, and BZ. If we want A minus vector B, we minus the each axis. We can write this, it may seem complicated, but it doesn't. So vector A minus vector B is equal to AX minus BX, AY minus BY, and AZ minus BZ. This basically means the first, the AX coordinate minus the BX coordinate to find the new X coordinate, the Y coordinate of A minus the B coordinate, the Y coordinate of B to find the new Y coordinate, and the Z coordinate of A minus the Z coordinate of B to find the Z coordinate of the new Z coordinate. Okay, now let's use numbers to make everything easier. Okay, so we use numbers. We will use numbers. So let's say A is 3. Let's say vector A has the coordinates of 3, 6, 9, and vector B has the coordinate of 4, 5, and 6. We want vector A minus vector B. Okay, now vector A minus vector B is 3 minus 4 is equal to minus 1. Okay, that's for the x coordinate, the new x coordinate. 6 minus 5 is 1 for the y coordinate. And then 9 minus 6 is 3, the new z coordinate. And that is the subtraction of algebraic vectors in 3D. Okay guys, now we're going to talk about the multiplication. Multiplication of vectors in 3 dimension. Okay, the multiplication of a 3D algebraic vector can be written as vector A, AX, AY, AZ. Okay, with a scalar number. With a scalar, let's say the scalar k. If you multiply this by the scalar k, you will get k times AX, AY, AZ. We can also write this as KAX, KAY, and KAZ. This just means we multiply each of the coordinates in the vectors x, y, z with the scalar k. Let's use numbers to make it easier because letters are very confusing. So you understand. Let's say we got vector A of 1, 6, and 7. Okay? And we want to multiply vector A, multiply it with a scalar of 3. So this means this means 3A is equal to 3 times the vector A, 7. So 3A is equal to 3 times 1. This is the new coordinate, the answer. 3 times 1 is 3. 3 times 6 is 18. And for the last z coordinate, 3 times 7 is 21. Not 9 plus 10, okay? 3 times 7 is 21. And that's basically it. That's the multiplication of vectors in 3 dimensions. I'm Dr. Muhammad Nur Hillman, and thank you for watching.